I think now time is enough. So let's do for B. And B IP address is this one, 2.6. And you should be getting something like this after converting B, and you have the subnet mask. Subnet mask is 255.255.255.0 is the subnet. You have to write both in binary, and after writing that, you will get network IP. And network IP will be 192. So check whether you got the same 168 and 2.0 is the network IP, and the broadcast IP is basically so same IP address but ending with 255. Check whether you got the same. And then for C, the device C, I'm going to write this 1.93. Sorry, 1.93, and then you have the subnet mask, and this will be 1.0 and this will be 1.255. That is device C. So your conclusion is which belongs to the same network? Out of A, B, C, which are the computers? What are the computers belongs to the same network? Yes?
A and C.
A and C, yes. A and C belongs to belongs to the same network. So how you suggest, because network IP is as network IP is same. Therefore, please write down, therefore A and C can be connected directly or using a switch, network switch. If you need to connect B to the same network, need to change the IP of B, or need to change the subnet mask of all to 255.255.0.0. If you change subnet mask, then also this can be accomplished. If not, we have to use a router to route to the second network, where you can find B. So these are the possible solutions. One thing is you can change the IP address. Very simple. If you change the IP address to 1.6, so this will belongs to the same network. So then A, B, C will all three belongs to the same network. Or you can change the subnet mask. Subnet mask of all to 255.255.0.0. So what will happen? So when you have, so this is A, so you have A, B, C, all three. But if you have the subnet mask like this, different subnet mask, maybe let's say you have 255.255, and subnet mask is for all three is 255.255.0.0. Then when you add this A and subnet mask, so you'll get 192. So can you tell the value? 192.168. So when you AND 0 with something, what you will get? 0. When you AND 0 with something, you'll get 0. Understood how to get this easily?
Yes.
So if not, if you're not sure, please ask, right? Because here you have all zeros here. You have all zeros. If you AND something with all zeros, you will get 0 as the result. So since you have 0 here, if you AND this 0 with anything above it, you will get 0. And you can see A and subnet mask is this one, B and subnet mask, and C and subnet mask is also. Just see B and subnet mask, B and subnet 192.168.0.0. This two will become 0, 0. C and subnet mask. So it's belong to the same network. So that is another trick. You can change the subnet mask, or you can change the IP address of, okay, let's say solution 1. So let's write solution by solution. Solution 1. You change the IP address. Keep the subnet mask as it is and change the IP address to 1.8 and subnet mask to 255. Then the network IP for A, B, and C will be 192.168.1.0. This is for all. And broadcast will be 192.168.1.255. That is the broadcast. So that is solution 1. Solution 2 is you can keep the IP addresses and change the subnet mask. Then also solution 2, you can change the subnet mask, keep the, so then you can see, and the broadcast IP will be 192.168.255.25. That is the maximum IP that you can. That is the last type, the broadcast. Solution 3 is, so what you can do, you can keep A and B connected via a switch. So let's draw, this is A. Let's draw as a diagram. This is A. This is the A computer. This is B computer, and this is C computer. We have 3 computers. From that, A and B can be A and C can be connected to the switch. So this is computer A, this is C, this is B. So you know the IP addresses of this, and that is basically A is this one, and C is this one. You can just connect that using a switch, 93. Then connect this using a switch. This can be connected to the switch. No harm, you can connect. But you need a router to connect from switch to this one. This is another network. If you are traveling from one network to another network, so this is another network, this is B. And so you can see this is subnet mask is 255.255.255.0 is the subnet mask. Keeping that subnet mask, if you want to go to the other version, so you can use. So there's a symbol for router, right? Okay, this is the symbol for router. I'm just going to use that. Switch also there's a symbol. So no need to follow the symbols, but if you can use, so this is switch, this is router, this is, there are basic changes, fundamental changes. Let's use the router. Instead of switch, you can use this one. So let's use standard symbols. So it will be, then it will be nice for a viewer because viewer will identify the symbol easily. So rather than naming this using labels, you can either use labels and name this in the exam also. You can use labels and name this. That is up to you. But even without labels, if you use symbols, the examiner will recognize, right? So this can be connected using a router. Here to here, we'll have router connection. The router can be connected to the second network. Okay, so I think you better write down all three solutions. So how to connect, change IP. So what is the easiest? Easiest thing is, what is the easiest? Yes? Change in broadcast, change in IP, or change in the setup, hardware setup, which is the easiest way? Sit me, Sachin. Yes. What do you think? What is the easiest way?
First one.
First one. Yes, change in IP is easiest. No need to do other things. Change in IP is 1 second thing. So let's do that and see, right? Let's do that and see. First, draw this, write the solutions. So these are the possible solutions. So I think you have copied the note, no? So this one, have you copied?
Yes, sir.
Up to here?
Yes, sir.
Right, okay. Just write the solutions there. Okay, so in addition to this, actually in the last video, last day, we learned about class ABC base, class A, class B, and class C base concept. We learned that as well. Just give me a second. Hello. Hello. Right, okay. So here is how these classes A, B, class A, B, C, and so these were, they are in the old networks. So class A addresses, class B addresses, class C addresses, like the private addresses, were divided to different ranges. So let me explain the concept behind that. Actually, that is a pattern again. So there's a pattern in this class A, B, C, D, E. Actually, D and E are not used, but class A, B, C computers, this network and host IPs are used. So let's see how these are used. I'm going to use another graphic here. So that's why I'm going to search Google class A, B, C, and so D and E IP ranges. So this has a pattern, right? This has a pattern. Okay, you can see. So I would like to use this one. Okay. Yeah, this is more explanatory, but the octet value should also be there. So let's take the one with octet value also, right? Octet value, octet value, octet value. Let's switch to the previous one. Okay. Okay, let's use this one. I'm going to use the same table, right? Same table that I have copied from the internet. And let's see how these addresses are, how these addresses are allocated. Right? Let's see how these addresses are allocated. The first class A address is basically so taken by reserving the first octet. The octet means this is how it's actually taken. So it's blocking the first. So I need to use two things together because, okay, you can see this pattern, leftmost bit pattern. So please remember this pattern: 0x, 10x, 110x, 1110, and 1111. This is how the leftmost digits are taken, right? 0 x x x, then 10 x x, then 110 x, then 1110, then 1111, and this is the pattern basically. So anyway, this pattern is not there in the table, so my suggestion is write down the pattern in front of table if possible. Then it's very easy to find the values rather than remembering this. Otherwise you have to by heart. Rather than doing that, you can just remember this pattern, and this pattern shows this nicely. So 0xxx means, so basically the first octet, you know, there are 8, so sorry, there are 4. In any IP, there are 4. Okay, how the range is calculated for class A? Basically, you have to take this kind of pattern, 0, that means you can change. So basically, the first portion is allocated. So the value of first portion is, this portion is allocated for the network, and this portion is allocated for hosts. Hosts means the devices in the network or the components that you can connect in the network. I can color this in two different. You can see here: net ID, host ID, net ID, host ID, net ID. So this is actually multicast, and this is the last one is reserved. I'm going to copy that as well. So there are 4. There are few concepts behind that. So let's take together and study. Then it's easy to remember. Okay, the first byte is reserved for the network. So let's say 1, 2, 3. How many bits remaining? 4, 5, 6, 7. All together 1, 2, 3, 4, 5, 6, 7, 8. Then the next bits are allocated for computers. 1, 2, 3, 4, 5, 6, 7, 8. Then next 8. Next 8. Okay, can you tell me the first valid host IP? First, so this part is for network, right? Making when the net. If you change this part, it will change the network. So since you have 7 digits for network, how many unique networks will be there? How many networks will be there? You have 7 digits for networks. So how many networks? You know how to find the number of combinations now because you have already done that. Kalinkarani, you have already done that. You know how to find this. If 7 bits, how many networks? 2 to the power? Yes?
7.
Yes, 2 to the power 7 is the theoretical value. But 0, you can't treat that as a network. The last one will also be ignored. Last one and the first one will be ignored. So it will be taken like this: 2 to the power 7 minus 2 networks. That's how the number of networks are calculated. 2 to the power 7 minus 2. So what is the value? Yes. 2 to the power 7 means 128. 28 minus 2 will be 126 networks. This is how this value is taken. And host IDs are also taken. How many bits for hosts? How many for hosts in class A? Yes. How many bits for hosts? 7 for. Yes, 7 are reserved for. 7 are reserved for network. So 2 to the power 7 minus 2, 126 networks. Because the first value is not going to take. This value you are going to keep it reserved 0. You are not going to fill this. So how many hosts means how many computers in a network, in a given network. So what is the number of, so you can change all these bits and create computers, connect computers. How many computers can be connected to a given network? Yes?
24.
24. Or 2 to the power 24.
To the power
2 to the power 24. So which means this number of hosts per network. Hosts per network. 2 to the power 24 hosts per network. So you can just calculate and see what is the value. So let's calculate that. 2 to the power 24. 2 to the power 24 is 24 is this number of hosts. So let's say hosts per network. Again, you have to subtract 2 from this. Why you are going to subtract 2? What's the reason? Because the first IP is the network IP, the last IP is the broadcast IP. First IP you are not going to take, that is network IP. The last IP is broadcast IP. To send all computers, you are using the last IP. First and last IPs you are going to ignore, so this will be this minus 2. And you can see the value is 16,777,214. 16,777,214 came like this. So because it's minus 2, so that is equal to 16,777,4. Anything unclear, you can ask now. So this number of hosts per network, the computer million, a network, in a single network, you can have 16 million computers connected to a single. That is a very large network, very large network. So, but these class A networks are used by very, very large companies. Class A networks are used by, private networks are used by very large companies because, so you can also use class A IP. That doesn't mean, but the thing is, so in this has wide range. Because only if you change this bit, only a network change. So understood what is class A network? Okay, class B network. Understood or not? Not understood or understood? No. Oh yes.
Yes, sir.
Okay. Sachini?
Understood, sir.
Okay. Then the second one, class B. Class B. Class B is obtained by this pattern, right? You have to preserve this pattern. Then. So let's have 0, 1, 0, XX, 1, 2, 3, 4, 5, 6, 7, 8. Then the remaining bits. And you have to make sure that the remaining bit, out of remaining bit, 1, 2, 3, 4, 5, 6, 7. Okay, these bits are reserved for the network. So remaining bits for computers. So can you tell me, right? So you can see this is the range 1 to 126. And so in some, for an example, in some, yes, you can see they have given the last valid IP, this 1.00 to 127.255.255.255. That is the last value. Different, the first value and the last value is given. So that's why I said if you're using this, you have to use like the starting IP is start. You have to use valid IP. Valid starting IP is 1.0.0.10, and the end value will be 127.255.255.255. So let's add that as well for this one. So you have to start from 1, 0, 0, 0, 2. You can change this to maximum. If you change, you will get 2127. So the maximum host number will be 255, 255, 255, 255. So that is the maximum that you can do in class A networks. But there's a special thing, this 1, 2, we are not going to use up to 127. you will use only up to 1 to 6. You are not going to use 1 to 7 network, 1 to 6. You are using up to 1 to 6 network. The reason is, so even though this is mentioned like it's valid, yes, you can go up to 1 to 7. I agree with that. But the thing is, 1 to 7 is specially reserved for 1 to 7 is specially reserved for local host. Here, therefore, in some network, it's given as 1.1. So these are the first host and last host, first valid host and the last valid host. So this is how they give. No, you can say start IP is this theoretically 0 and theoretically this is the end IP. But practically when it comes, it is, so this is a practical range. So practical range will be, so there was one showing the practical range. Is this the one? No. Okay, here, this shows the practical range. Address range is 1.0.0.1 to 126. That is the practical range. Okay, you write like this. So, but let's write the practical range too. Practical range will be 1 for hosts is 1.0.0.1 to 126.255.255.254 is the, this 255 if you use, it's used for broadcasting. Therefore, this is the range. And 127.xxx is reserved for local host loopback. Something called local host loopback, and this is the actual picture. But theoretically, if someone asks, you can say the range is 0, so 0 to 1 to 7. This is the theoretical range. Theoretical range. Okay. What is the first valid network? Can you use 0, 0, 0, 0 as a network? No. The first valid network is 1.0.0.0. The first valid host IP will be 1.0.0.1. The last valid host IP will be 126.255.255.255. And this is the range. These are very important things. Okay, then, so can you tell me the same for class B? Class B. So how many networks? How many networks? Come on. Class B, how many networks? How many bits reserved? Quickly tell me now. This is going to end. We are going to end the session. If you're okay with this, I can give that other thing as a homework. How many bits are reserved for the network? Sachini, you said you understood. Yes, how many bits reserved for the network in class B? 14. Yes, then what is the value? This one will be 2 to the power 14. 14 minus 2 network. That is how many bits? Finally, how many networks? Yes. How many networks? You can calculate 2 to the power 14. 16,384 networks, but minus 2 will also come, right? You can just copy, and so you can say it is 16,382. So see here, it says 384, but the first and last will be ignored. So here actually you can keep the first and last. So you can say 16 because the first is not 0, no? You can keep it. 16,384 networks. And how many hosts? So will be here 8 plus 8, 16 minus 2. And you can tell 2 to the power 16 is this value, and you can just subtract 2 from that.